right. Welcome, everyone. I'm Philip Luer, and I am Director of Ecosystem and Developer Evangelism for Machine Learning at ARM. I'd like to welcome all of you to the AI Virtual Tech Talk. And this is a series of Tech Talks, and we'll be launching more of these Tech Talks soon. These Tech Talks are hosted by experts, really the brilliant minds from our AI partner ecosystem and ARM, where the presenters are talking about the latest trends, technologies, and best practices in this incredibly broad world of AI. I mentioned that we will have more Tech Talks soon, and we're also really excited about launching very soon our Asia Pacific series of Tech Talks. So stay tuned for that. So a few things before we get started. The slides and the recording of this session will be available in about 24 hours. If you have questions, please submit those questions in the Q&A box below. And also, if you want to reach out to us, you can tweet us at ARMSWDev using the hashtag AI Tech Talk. So without further ado, I think you all know who this is. I will introduce him nonetheless. I'd like to introduce you now to Massimo Banzi, who is the co-founder of Arduino. So Massimo, over to you.
Thank you very much. Thank you, Phil. And yeah, it's great to be here. I'm going to be talking a little bit about how people build tiny machine learning applications on Arduino and some of the different options that people have. And I will show you some examples of also projects that people have built. First of all, let's look at a very quick definition of tiny machine learning. This is taken from the tinymachineLearning.org. So it's broadly defined as a field of machine learning technologies and application, including hardware, algorithms, and software capable performing on-device sensor data analytics at extremely low power, typically in the milliwatt range and below, and hence enabling a variety of always-on use case targeting battery-operated devices. In my case, I always call it like taking advantage of machine learning right where things are happening. So if you have your little microcontroller device that's sitting exactly next to the sensors, where the sensors are, where things are happening, so you can apply those kind of machine learning algorithms on this kind of constrained hardware. But it's kind of funny because what is considered now constrained hardware just a few years ago was an incredibly powerful machine. So, and obviously, I'm the co-founder of Arduino, and in Arduino, one of our missions is to enable anyone to innovate by making complex things, complex technologies simple to use. And one of the things that we try to do in Arduino is always to figure out if there are things that can be made more understandable, simpler, that can be explained in a different way, because in a lot of situations, some technologies, they look very complex because they are usually presented as something that is only for a specific audience of very advanced users. And then finally, you realize that explain in a different way, it becomes much more understandable. So this is an ongoing mission for us. Just a few numbers about Arduino. I mean, every one of you probably knows about Arduino, but we are pretty popular. We have millions of users coming to the website, millions of active users on our online platforms, and our social media platforms are quite popular. So join us on our different social media platform, because one of the things that we do is share constantly the kind of projects that people build with Arduino technology. So it's always interesting to see what other people are building. It's a good source of inspiration. One of the interesting features of Arduino today is this idea that we figured out that the simplicity, the Arduino, in a way, the method, the recipe of Arduino that was designed for beginners, it's actually evolved into something interesting where it is, yes, easy for beginners, but it is fast for professionals. A lot of professionals are now using Arduino because it's very fast, it's very quick, they can get results very quickly. And so let me just give you a quick overview of some of the things that we are doing at Arduino that are a little bit different than what we used to do, maybe to the kind of hardware that a lot of people are used to. So one of the interesting hardware that you will see mentioned several times during the presentation is this Arduino Nano BLE sensor, which is a very tiny stamp-sized board, which it's powered by an ARM Cortex-M4F from Nordic Semiconductor. It's got a 1 megabyte of flash, it's got 256 kilobyte of RAM, Bluetooth, technically supports Bluetooth 5, and it's got a bunch of sensors on board. So IMU, 9-axis IMU, microphone, gesture sensor, light sensor, color sensor, proximity, pressure, temperature, humidity. So basically, this combines a quite powerful processor with a bunch of sensors. So in a way, you have a platform that's ideal for a lot of these TinyML applications, because the combination of sensors and processor allows you to build a lot of interesting applications without actually needing to add any hardware. In fact, out of this little board, we built this kit called the Tiny Machine Learning Kit, which couples a simple VGA camera and this board, which has been used also in a number of educational settings. For example, this kit that we put together was the result of a collaboration between us and Harvard University, where there is this class which is taught by Professor Vijay Janapareddy, who is work with us to basically bring this TinyML class together, and we kind of built this little kit with the camera. So, the students in this class are doing computer vision on a Cortex-M4, and they have interesting projects. So a lot of the material for that class is available on this link that you see at the bottom of the slide. But then Professor Reddy, out of this class, created this edX professional certificate. So you can study online using this kit, and you can learn about tiny machine learning and get a certificate from Harvard. So it's quite a very interesting opportunity, and it was very great, very, very nice project. Really love the work that we did. So in a way, that's an interesting, in a way, output of this work that we did. Interestingly enough, on the same hardware, we started to work with companies that work in agriculture. Our partner in this case was a French company that called Challenge Agriculture, that works mostly in automating and putting intelligence in irrigation. So we put together this device, which is called the Arduino Edge Control, and it's powered by the same processor as the Nano BLE Sense with Bluetooth, but it's got all the different rugged inputs and outputs and all the different circuitry to build something that you can literally place in the middle of a field to drive irrigation, to apply little machine learning algorithms from sensors directly in the field. You can plug different other boards to include different kind of connectivity. So it's quite an interesting product, and this one is being evaluated and used by a number of people who do agriculture. So it's a kind of a new direction for Arduino. And the other one that's an important, in a way, direction for Arduino is this Portenta H7. It's essentially an interesting piece of hardware, because it's essentially a module that contains a ton of different hardware, very powerful hardware, very packed on a small device. It's got a dual core Cortex-M7 plus Cortex-M4 microcontroller. It's got a lot of memory, a lot of RAM, a lot of flash. It's got Ethernet CAN. The USB-C plugs even supports DisplayPort, so you can actually generate video if you want. It's got a battery charger, and also Wi-Fi and Bluetooth, plus all the crypto you need for secure communication. So this little module has two high density connectors at the back, which are 160 pins. So you can snap this module on different boards. So for example, this Portenta Vision Shield allows you to do computer vision application using this very low power camera from Himax and microphones from ST, and you can get it with the Ethernet or LoRa connectivity. And I'll have an example later of a computer vision application done with this combination. These are some pictures of the two different options. And this is a short video of a customer who put this camera combo on a robot arm, and the device is actually looking at fixtures that are assembled in a car factory to figure out if the person who put all these different parts didn't forget a specific part when they assembled. So it's interesting because, again, the whole computer vision is happening in the device. There's no cloud, there's nothing else. So it's quite useful in this kind of scenarios. So if you want to then use this in the field, you have different options. One option is this Portenta breakout carrier. You snap the board on it, and a lot of the I/O is broken out so that you can use it to build your own application. There are different types of camera connectors, gigabit Ethernet, SD cards. So there's quite a lot of expansion possible. And another one that's very interesting and very new is this Portenta machine control. This is a piece of hardware where you can, again, snap a Portenta, and it's essentially an industrial controller. It supports all the different protocols like CAN, RS485, Ethernet. It's got, yes, Wi-Fi and Bluetooth. And all the inputs and outputs are industrial standard and rugged. Also, one thing that I should clarify and mention is that both the Portenta and this hardware are designed and manufactured to industrial standards. So they are designed to withstand a very wide range of temperature and, in a way, stress of different kind that you find in an industrial setting. There's also this board that has been sort of quietly pre-announced. It's a tiny little 23 by 23 millimeter board, which has a similar processor to the Nano BLE Sense. It's a Cortex M4 as well. Comes with a bunch of very high-end sensors from Bosch. And this is a new format we have been working on of something that's a small module that can actually operate in a way independently, or can be mounted on top of another board. So you can see this as USB, but it's also got a connector so you can connect it to something else. So this has a lot of, it's got an IMU and a lot of environmental sensors. So you can actually build a lot of very interesting applications with this thing that are very low power, taking advantage of the super intelligent sensor you have. Then this module has Bluetooth, BLE, usually Bluetooth Smart. So there's a lot of battery powered application that you can build with this pre-made module with very high-end sensors in less than 1 inch of size. So this is, it's going to be widely available in September, but Bosch, our partner, started to kind of talk about it. And this is a new format that we are working on. Quickly touching on a couple of things. So we have a new development environment for the ones that haven't heard about it, the IDE 2.0. It's quite powerful. It's built on the same kind of framework as Visual Studio Code. It supports debugging of ARM boards and, sorry, I got distracted by the chat. So this IDE, it's got autocomplete, it's got debugging for the ARM-based boards. It's got a lot of very advanced features so that it can be used for professional development, but it's got all the great features that you find in the classic Arduino IDE, like the library manager, the core manager. Also, the interesting thing that we just recently added is that if you use the online IDE by Arduino, the one that works in the cloud, you can actually keep the sketches, the software, the programs that you're developing locally synchronized with the one on the cloud, so that you can keep them in sync, or you can use it also to back up your code to the cloud. And that's part of our Arduino cloud, and it's a great feature that you should check out. Another interesting thing is that we started to collaborate with OpenMV. OpenMV, they do very interesting products that do computer vision on microcontrollers, powered by a special version of MicroPython they put together, where they have an IDE that it's a cross-platform IDE and a special version of MicroPython that runs on microcontroller. They ported it, so we collaborated with them. So they ported it to the Portenta H7. The Nano BLE is coming soon. So you can actually build different kind of tiny machine learning application in MicroPython using an IDE that kind of makes the whole process super simple to follow. So this is a kind of an overview of the different tools that the current Arduino makes available, because I realize that despite our best effort, a lot of people sometimes don't know that there are all these new things that Arduino has been working on. So, I wanted to level the field and understand that, show to people that we are doing quite a lot of work to also, in a way, work with what is can be defined as the professional world. More and more people in the professional world, in the industrial world, in agriculture are using Arduino, and we are building professional hardware and software and cloud for them. So let's delve deep into some of these examples. First of all, I wanted to mention that a lot of the material that you see in the first part of the presentation, if you want to understand more about tiny machine learning and TensorFlow, you should check out this book by Pete Warden and Daniel Situniake. Sorry if I'm bad at pronouncing his last name. Sorry, Daniel. But the idea is that both of them worked at Google when they wrote this book. Now Daniel works for Edge Impulse, another company that we will talk about later. This is a gentle introduction to using TensorFlow on microcontrollers. So if you're interested in this topic, you should totally check out this book, because the first example I'm going to show you uses TensorFlow on microcontrollers. So as many of you know, TensorFlow is a very, very popular machine learning framework from Google that's designed to run on really big computers. And in this situation, they found a way to squeeze TensorFlow so that it can run on a Cortex-M4 microcontroller like the one on the Nano BLE Sense. So you have this TensorFlow Lite for microcontrollers. So I'm going to show you an example of gesture recognition using the Nano BLE Sense and the fact that you have this 9-axis IMU on board, so accelerometer, gyroscope, and so we're going to be using mostly the accelerometer here. So you can follow this tutorial, and I'm being told that after this presentation, a PDF version of this presentation will be made available. So if you can't read the URL fast enough, you will be able to find the material. So this is an example that was written a while ago by Sandeep Mistry, and it's using TensorFlow Lite to build a simple application, which is a gesture recognition application that turns gestures into emojis. So you can build some kind of an emoji keyboard. So let's look at the process a little bit, just to show you the process of this kind of project. So in this case, we have a sketch called IMU capture that you install in the Arduino, and it captures the data from the IMU, so the accelerometer in this particular case, and displays it on what we call the serial monitor as some kind of a CSV representation. So in this case, you can see that accelerometer and gyroscope as produced as essentially as a CSV representation. And one of the things that we can do is to basically make different gestures and then cut and paste this data and set it aside so that we can use this data to then train our algorithm. So phase one is get the data out of the microcontroller, do different gestures and save the data as files. You can see here through this thing that we call the serial plotter, all the different parameters of acceleration and gyroscope visualized depending on two different gestures. Here's a little animation that shows you the person doing different gestures. So once you have all that data and you captured it into CSV files, in this case, the system is programmed to detect punch and flex. So once you have that information into a file, then you can go to this collab. So obviously, I know a lot of you will know what a collab is, but effectively is a way that you can run Python code in the cloud using this interface, where basically it's a mixture of code and in a way textual instruction. So if you click on this, on the URL that you will see in the link I shared at the beginning, you end up on this page. Here is the actual URL of the collab. You basically drag the punch and flex CSV onto this page. You press the button, and a big process starts of basically training a TensorFlow model on these two files with examples of punching and flexing. After that, the model, after the training, the model will be processed by this collab, and it will basically generate a .h file, which is essentially a model compatible with TensorFlow Lite Micro that you can place inside of your Arduino code. So if you open this sketch called IMU classifier, you place this .h file in your project, you press the button, and you basically get something like this, which shows once you punch and you flex, it shows you a percentage of confidence that the gesture that you just did is either a punch or a flex. So you can see that some are very clear cut. So one is 0.9999, while the other one is 0.87, but it is quite useful. I have it running here, but I'm not sure I want to interrupt the screen sharing before it maybe creates a problem. So here's a little animation that shows the completed project uses a sketch where Arduino simulates a USB keyboard. So every time the algorithm understands one gesture or another, it basically sends the keyboard representation of this emoji to the machine. So let's move on to another example that's a little bit more sophisticated. So for this one, we're going to use the Arduino Portenta, so a very, very powerful microcontroller, using the low power camera plugged on top. And this is using OpenMV, but it's also using a service from this company called Edge Impulse that you will also see mentioned later, which a lot of the, they provide a platform that simplifies a lot of the steps of going from, in a way, the data, the training, and the generation of the code that can actually do the inference on your device. So in this particular project that was developed by Sebastian Romero at Arduino, we are using the Portenta with the Vision Shield and a little USB cable. And in this case, we need a bunch of fruits or other objects to create a classification model. So the idea is that we're going to take a bunch of pictures of different fruits using the camera on the Portenta, and then we're going to send these images to this Edge Impulse cloud, and the Edge Impulse cloud will crunch all this data and send us back a piece of code that can run inside OpenMV. So in a way, you can create you can use the OpenMV IDE to create a new data set. Then you can start to take pictures And then once you collected a bunch of pictures of the different fruits that you want to catalog, it can also be any other object, then you can log into the Edge Impulse account and send this data set to them directly from the OpenMV IDE. And then it shows up on their platform like this. You can see here a black and white picture of a banana in that case. In this case, there were 1,142 images collected and 4 different labels, so 4 different kinds of fruit. Then if you follow their platform, I'm not going to go into the details of how this works because you can also try this for yourself for free, but in a way you provide a number of indication on how to process the images. In this case, it's squeezing them to 48 by 48, and then it applies this transfer learning, and then you generate 4 labels: apple, bananas, pear, and unknown. So you press the save impulse, and then it's basically you go through the process of generating the different features. Then you can see here the features that were extracted by this data set that we provided. And you can monitor in the corner, you can monitor the process of going through the different images when the training is happening. So here you can make sure that the model is correctly trained, and you're basically ready to export. And here you have a bunch of interesting examples of different things you can generate. So you can actually generate this as a straightforward Arduino library. So you can put this into your Arduino C++ code, and it will be exported exactly like any random Arduino library. So it will be plug and play compatible with Arduino, or you can export it as an OpenMV library. It's interesting because you can also export this as a CubeMX CMC spec. So for example, if you are a CubeMX user and you have a Portenta, which is an STM32 processor, you can export it for that route as well. And you can even export it as a WebAssembly, which is quite interesting because you could actually run something like this inside a browser. The actual code, once you generated this library, the actual code that does the, in a way, prediction, if you want to call it, is essentially just these few lines of code. And here you can see the code running inside the OpenMV IDE, which has this area in the top right where you can preview what the camera is capturing. And over here in the bottom, you can see how the algorithm is detecting the different object, and if it's able to. In this case, it was 100% sure that this is an apple, which is great. And you get reasonable frame per second speed, considering that, again, you program this with Python. This is a microcontroller. Also, the camera that we use on the Portenta Visual Shield, it's designed to be very, very low power. So it's not a super high resolution camera because it is designed to use as little energy as possible so that you can run this even powered by a battery. I wanted to touch also very quickly on an interesting new member in the Arduino AI family, which is this framework called IFES. This is developed by this research institute from Germany called Fraunhofer IMS. So they developed this pure C library to do tiny machine learning that's compatible with Arduino now, and they open sourced it, so we work with them to open source it. The nice thing about this being pure C, it's very, very lightweight. So it has a number of interesting features. For example, you can even run it on an 8-bit Arduino. Clearly, doesn't make a huge amount of sense, but you can do it if you want to, because it's very, very, very low level. But if you're running on an ARM processor, it takes advantage of a lot of other sort of accelerations in a way. So it's actually quite powerful. And the other thing, sorry, my presentation skipped ahead. One of the other interesting things that you can do with this library is that you can actually do the learning in the device. So you will notice that most of the tiny machine learning, if not 99% of the tiny machine learning example that you see somewhere, they are designed to collect the data from the board, send it to the cloud processes the data and sends back a piece of code that you can put in the board. While in this case, if you write the code correctly, you can actually perform the training locally. And this is actually very, very powerful because it allows you to build devices that you press a button, they learn, and then they proceed with that information. You can see here a little example of their gesture capturing example, which is similar to the first example that we built, but instead of being based on TensorFlow, which is quite a large piece of code at the end, this is built with very, very little code. Consider that using the 8-bit microcontroller connected to a trackpad, they can do digit detection. So it's quite powerful. You find it on ifs.ai. It's open source. You can, but you can also license a commercial version if you want to use it in a product. So check it out. They did a pretty amazing work here. Just showing you a little few examples of what people have done with Arduino that we don't have time to go into detail, but if you go to the Arduino blog in the category that says machine learning, you will find people that have built, this is a device to detect respiratory diseases in pigs, or a device that understands the dog mood depending on the bark, or a device that detects when somebody has a fall, or in this case, it's interesting because it's a bracelet designed to detect the sign of epileptic seizures. So there's a lot of very, very interesting application that you can do using Arduino. I'm going to do a very quick, going towards the end of the presentation, I'm going to do a quick kind of flyover of some of the different software options that you have if you're doing machine learning on an Arduino hardware. So obviously, if you're using the Portenta, you can use STM32Cube AI, which is a quite sophisticated and powerful tool, which is probably for people that are quite experts. It's not exactly a tool for beginners, but it's very, very powerful. Obviously, we mentioned several times a Gimpulse. In this case, for example, this specific tutorial is about using the microphone on the Nano BLE Sense to detect voice. I remember a few months ago, somebody even developed a piece of code that would detect sneezing and coughing. So it was in a way to detect if somebody was showing some kind of early sign of, COVID or a flu or something. So it's a very interesting platform where a lot of the complicated behind the scene of preparing and training and exporting a model is all taken care of by their cloud. Quixo is another interesting example. You can see in the URL underneath a link to an example they built. Again, it's a tool where you capture the data into the board, and then their cloud will allow you to select a certain model, choose the type of model, train it, and generate a piece of code that you can bring back into Arduino and run the inference in the device. They also have some interesting feature. They implement some for a form of AutoML. Their tool is called Quixo AutoML. So you should check it out because it's very interesting. And also this other platform I've only seen it recently, so I don't know very much about it, but I can see that they use the Nano BLE Sense again also to build examples. It's another platform to make it much, much simpler for people to build functioning TinyML devices. And so you should check it out. And finally, Google originally developed TensorFlow and TensorFlow Lite for microcontroller has commissioned a number of creative coders to build some experiments So you can, they made it a little bit simpler to use TensorFlow, for example, for detecting gestures and for building all sorts of other applications. You should check out this website, experimentswithgoogle.com. And then if you go to the homepage, there will be a TensorFlow Lite for microcontrollers. And there are some examples that are open source that you can follow and you can build your own applications. So I think this is a nice way to build some quick creative projects that are fun and get you to start understanding how this works. And that's it for me. Thank you very much. I think
Yeah, I can jump in.
Yes.
That's one here. Here we go. Hey, so we are ready for Q&A. And I know we've got quite a few questions here. Just to remind everybody to please use the Q&A tab for your questions. And just again, before we get into it, you can see here, you can reach us on our Twitter channel. And also you can see a link here to sign up for our tech talks. And please, at the end of the session, please don't forget to fill out the survey to have a chance of winning an Arduino Nano 33 BLE board. And as you can see, it's the gateway into TinyML. So please check that out. Okay. So Tobias, I guess we just kind of jump in here.
Yeah, go for it.
Okay. So let's jump into one of these questions here. We'll answer this live here. So thanks to you, Massimo, for building a great mission and commitment with Arduino. And the question from Wilmer here is, what is the computer vision library used in these boards?
Well, interesting. Well, on the Portenta, it's we have a drive for OpenMV. For example, OpenMV has a driver that allows to bring the images into MicroPython, and then they either have a bunch of different algorithms already implemented in MicroPython, or they have sort of an interface on top of OpenCV. But in this particular case, they were using then TensorFlow as the engine, while in the project that you can build with the Tiny Machine Learning Kit, again, we are using Arduino code that captures the data from the camera and passes the frames onto TensorFlow. So in this case, we are using, this is the process that we used.
Okay. So we have another question here regarding training on device, and you mentioned the Ives stuff with Fraunhofer, which is really interesting. So the question is about the fact that in general, as you mentioned in your talk, most of the training is done in cloud. There's starting to be some emerging training being done on device, such as you're doing with Ives. Are there any other collaborations that you're doing in this space? There's a person mentioned here of HiUren and others that are looking at doing research on this topic.
So I was not aware of HiUren. I will look into it. At the moment, what we do is basically it's basically mostly the work that we have done with Ives, where you can do training. Otherwise, there are ways where you can sort of automate part of the process, because it is technically possible to capture data from the device and then use a connection to push the data to a cloud. And then in the example that I've shown, the model.h was a file that was compiled with the firmware, but nothing stops people from building a firmware that can update the model on the go. So you can push the data to a cloud, and then the cloud sends back a binary file that you can place in memory, and then you can sort of run. Then you can run with the new model.
Okay. All right. So next question is there a way of running models on an Atmega 329P or the Arduino Uno?
Yeah, so as I mentioned, this IFS supports 8-bit Arduino because it's written in pure C. So technically it runs also on an 8-bit Arduino. Clearly, you have to understand that you're dealing with an 8-bit processor that has basically 1 or 2 kilobytes of RAM and 32 kilobytes of flash. So the amount of machine learning you can do is quite limited.
Okay. Next question is, any dates on when the support of OpenMV for the Arduino Nano BLE is being released?
Unfortunately, I don't have a firm date. There was a slowdown in the process for one of the person that was working on it has some personal things they had to deal with, so there was a slowdown a little bit. So I don't know exactly when it's going to happen. I know it exists. What's missing, it's all the part of integrating it properly inside the OpenMV IDE, and also from our side produce all the documentation, because obviously it requires replacing the firmware in the board. So there's quite a few steps that need to be done that are not ready yet.
Okay. All right. There's another question. This one is around Bluetooth, and basically asking about sample code for collecting sense data over Bluetooth to the Nano 33 BLE. This is for an application where where you're not tethered to a PC via USB cable.
Okay, yes, well, there are two places where you can look. So if you look at this TensorFlow experiments with Google that I mentioned at the end of the presentation. So if you go to experiments.withgoogle.com and you click on TensorFlow, the way they are building this thing is basically that they are collecting the data on the microcontroller, and then they are sending the data to a web page through Bluetooth, and then they run a piece of code behind the web page that crunches the model and sends it back again via Bluetooth. So that is a practical example on how to do that. And also the other thing is, another possible is that there is an example that you can find of the Nano BLE sense using Web BLE to talk directly to a web page. So we built this dashboard that shows all the real-time data from the sensors directly via Bluetooth. But I would say the Google example is probably a very good place where to start.
Okay. Now I have actually two questions which happen to be together on a similar topic, which is around the choice of programming language. And so the question is, do you think, in terms of the TinyML space, do you think most people would use C++ or Python? What are you seeing? What's the preference?
Well, so I think it depends on the use case and the stage of the process. In my opinion, when somebody's trying to build an end product that needs to be developed in sort of quite a large quantity, obviously whatever you can optimize, it's important. So I see a lot of people using C++ or Arduino on top of C++ because you can compile it to a very optimized binary. So obviously for that kind of obviously there's a bunch of people in the machine learning world that are using Python on their sort of computers to do machine learning. So clearly doing MicroPython on a hardware device makes a lot of sense for those kind of people. So I would say for developing, experimenting, prototyping, learning, MicroPython is great, and there will be a lot of people using it. But I would say if you are building a commercial product that will be built in millions of units, we will probably still see a lot of C++ or even
C++.
C.
Okay. Okay. Question coming back to for the gesture recognition, in terms of the ML models, are they time series based? what type of network is being used in that model? Is it LSTM or some other type of model?
So at the moment, I don't remember which model has been we used for the gesture based. So you should, the code is open, so you should check it out. At the moment, I don't remember. I think in that particular case, it was a time series based, so nothing.
Okay. So, a question about in terms of microcontrollers using an RTOS. So when you're running TensorFlow Lite for micros on the Arduino, are you running it with an RTOS? If so, which RTOS? Is it possible to have an RTOS at the same time?
Oh yeah. So if you're the example that you see running on the Nano BLE sensor and the Portenta, both versions of Arduino are developed on top of embeddOS. So they are already running on an RTOS. So it's interesting because you can use them as your classic Arduino board and don't worry about the RTOS and everything is dealt for you. But then if you want to access the RTOS, there is a way to actually access any of the embeddOS functionality within Arduino code. So you can take advantage of all the feature of embeddOS, which is quite extensive, covers a lot of use cases, and obviously is quite optimized on all the ARM devices. So it is, in a way, when you're working with those kind of boards, the RTOS comes for free.
Okay. Now there's a question about, let's call it, I'll call it TinyML, which is, there's been a lot of talk about like the Raspberry Pi Pico, for example, and what's the smallest microcontroller that you've worked with that has supported TinyML?
Well, so this depends on the way you look at it, but in this particular case, well, I said IVES supports 8-bit microcontrollers with 1K of RAM, and obviously, the amount of real work you can do on that one is very, very limited. But for example, the Quixo platform supports the SUMD21, which is essentially a Cortex M0 Plus running at 48 megahertz. So it's a quite small and very lightweight platform. So it runs. You can run quite a number of different applications. And obviously, the RP2040 will also support most of this software. I would say we never tried IVES on it, but it's potentially doable. Clearly, if you use a Cortex M4F like on the Nano BLE sensor, you suddenly take advantage of a number of accelerations that the Cortex M4F gives you. SimSys has specific ways to accelerate that. So, and also Cortex M4F right now are quite lightweight as processors in a way.
Mm-hmm. But as you said, with like the Nano, the RP2040, you're starting to see some use cases run M0 plus, like really tiny.
At the moment, I haven't seen, personally, I haven't seen, I know people are talking about it, and I know that somebody demonstrated TensorFlow Micro running on it, but the Cortex M4 was still a little bit faster, but because of the accelerations that are inside the processor. So, but yeah, the RP2040 will also run a lot of this.
Okay. Okay. So there was a question about sort of the approach. We know, for example, for the Portenta, you're using ST Micro, and in many cases, the ST Micro software works in conjunction with Arduino. Or do you see, I guess, is there a difference in approach in terms of, let's say, TinyML and how you do going from cloud to Arduino devices? Is there a sort of recommended methodology tools in terms of the Arduino tool set versus other tool sets? How can you compare and contrast approaches? I mean, I guess another way to ask the question is, what kind of methodologies are you seeing in terms of how people are using Arduino and TinyML with respect to their tools?
So, for example, well, it depends on the application, because, for example, if you some people are just using the Portenta as a module for some hardware they're building, so they can build the code with Arduino, but they can also build the code using standard STM32 sort of development tools that the ST provides. So in a way, they are using that particular hardware essentially as a hardware module with a super powerful processor packaged up, snappy and ready to go. The advantage of working with the Arduino framework is that obviously, if you've developed quite a bit of work, quite a bit of code with Arduino, and you're very familiar with Arduino, you're also very familiar with the whole method of working with Arduino libraries. Obviously, a number of the tools that I was showing today, they basically generate an Arduino library. So for the user, once they train the algorithm, essentially what they get, it's a library they can just add to their Arduino IDE, and all the complexity of running that particular algorithm is packaged up inside the library. So it enables a number of people to actually build quite interesting and somehow complicated applications, basically integrating into their Arduino workflow. So in a way, it depends on what kind of code you're developing. So I would say if somebody is used to working with different kinds of Arduino and want to scale up to a very powerful board, they go to the Portenta, and without changing very much in their code, they are porting everything to a Cortex M7 that runs at 480 megahertz, and you still have a Cortex M4 as a spare to do other things. So in a way, you get that migration path and this kind of ability to package up the models. And also, Arduino has thousands and thousands of libraries that you can use to build things. So clearly, you have access to all of that. If you're kind of starting from scratch, you have to basically build all of these things yourself. So it's more indicated to somebody that either already an expert in this kind of STM32 tools, or they are kind of an expert embedded developer already.
Okay.
And then the MicroPython is a completely different direction as well. Okay.
So I know we're coming down to the last few minutes here. I think, Massimo, what I'd ask is if we don't get through the questions, would you be okay with, if we get the questions, we can kind of handle them offline via a blog or some other way that we can, answer these questions outside of video?
I mean, yeah, no problem. Yeah.
Because the questions are coming in, which is great. I'd like to thank everyone for the questions that have been submitted. We're definitely going to run out of time here before we get to all the questions. The next question I'd like to do we've got, again, a few more minutes left so we can get a few more questions in, but you'd shown the gesture recognition examples. There was like an edge impulse based example. There's IVES. And I think you'd mentioned the difference in terms of training in the cloud versus training on device, but anything else you can say in terms of just kind of comparing the different approaches of the two different ways that you could capture gesture recognition, or any other type of workload in terms of, edge impulse, IVES, other types of approaches?
Yeah, so it depends. It depends on the type of I guess it depends a lot also on the experience that the person has at this kind of machine learning applications. So each approach has their own advantages. So for example, if somebody has already experience with TensorFlow running on a computer, they can learn enough to try to take that model and squeeze it down to run it on a microcontroller. So if they come from that direction, the TensorFlow Lite micro obviously helps quite a lot. If somebody is a bit of an expert in machine learning and can actually kind of design their own neural networks and all of that, obviously IFES has the advantage that it's in a way, you know, it's kind of a more low-level tool, but you can basically build quite lightweight and very optimized algorithms and neural, you know, your networks and so in a way, it requires quite a lot of understanding of how to design your own, you know, network and the models and everything. So it's quite, you need to be an expert a little bit in machine learning in order to use it effectively. But then you get a lot of optimization. It's very lightweight. It can run the training directly on the device in certain situations. So clearly, I think the Edge Impulse, and there are similar platforms that I mentioned, have the advantage that if your objective is to get things done and you just want to, you know, for example, in the Edge Impulse website, you have certain kind of machine learning tasks that are essentially one button away, you know. So if you're capturing audio from the microphone and you want to recognize a certain sound, you press a button, you follow the instructions, you capture the data, it goes on their platform, it crunches, then at the end you choose, do I want an Arduino library or a MicroPython library? I click the button, I put it in my code and it runs. So depending on the kind of user you are, each tool kind of covers one of these areas.
All right. Tobias, we are down to the final few seconds here. Do we have time to squeeze one more in, or are we wrapping up?
I think we can squeeze one more in. Let's go into extra time.
I have a little bit more time if you guys want. I know you have other things to do, but a few more minutes I can stay if you want.
Okay, we can squeeze in a few more questions. Is a interesting one in terms of our Arduino capability, which is a Wilson camera. I'm doing my air quotes here. A Wilson camera is used for detecting elementary particles coming from the space on Earth. There's Arduino devices, or are there sensors that exist for such detection?
I wouldn't be able to point to something right now. I know years ago, I found somebody that made a project online that was that had a device that was basically capture radiation coming from space, but that was probably the only time where I saw something like that. I'm pretty sure that somebody has done it because Arduino is used in every university or company as a way to, you know, develop and experiments and do research. So I'm sure it exists, but I don't. Not something I'm an expert. I don't know exactly where to point to find this thing.
Okay. And coming back to the programming language question, there's an interesting one here that I'm trying to find regarding basically, and this is getting into now edge processing, right? Mm-hmm. So when as there's an increased move towards edge processing, and there's increased ability to do more on Cortex-A processors being deployed in various types of endpoint AI scenarios. Mm-hmm. Does Python become the norm of embedded and ML applications in the future?
Well, depends. So in the kind of application that we call tiny machine learning, it's not the norm. It's one of the tools. Clearly in what you call more sort of in machine learning on kind of larger type of devices, clearly a lot of people use Python to develop. And again, you know, a number of C++ frameworks that used to be available kind of been more or less slowly supplanted by Python-based platform. So it really depends on the kind of device you have and the amount of computing power. And also it depends how important it is for you to be able to run, for example, on a battery, on how important it is for you to run on a very, very small device. So the moment you have a Cortex-A running Linux, then people tend to use a lot of high-level languages, including Python, in a way to drive maybe TensorFlow or PyTorch or different other tools. But it always depends on how big your device can be and how much power you can use. If you are in the middle of, I don't know, a field, maybe, you know, or even something that can be mounted on top of an animal, for example, then you need something that uses very little battery and all that. So you obviously, that squeezes the kind of hardware you have available. So the C++ type framework that I talked about are a little bit more optimized for that.
Okay, all right. So I think with that, we're going to wrap up. I'd like to thank all of the participants, all the attendees. Thanks for joining us. Thanks for listening to the presentation. Thank you very much for your questions. As I mentioned before, for the questions that we didn't get to, we will answer them via some type of blog or other mechanism. A couple of reminders, please, once again, please to fill out the survey. You get a chance to win the Arduino Nano 33 BLE board. And also a reminder that we have the ARM Dev Summit coming up in October. So please check that out, sign up, attend, and there'll be a competition there too, which you'll get, which is pretty interesting, which you'll see more details on the website. So once again, thank you for attending. Stay tuned for future Tech Talks. I want to thank Massimo for joining us today, for going through the talk. Really, thank you very much, Massimo. Also like to thank Keith, who was behind the scenes, helping us out with some of the questions, and Tobias for pulling this together. So thank you, everyone. See you later.
Thank you.